Four 1 liter flasks are separately filled with gases, hydrogen, helium, oxygen, and ozone at the same temperature and pressure. Full stop. The ratio of the total number of atoms of these gases present in the different flask would be. So it is a good question, and they are asking you what actually the ratio of the total number of atoms. This is very important. You should be always taking care whether they are asking you the total number of atoms or molecules. So we know that whenever molecule is given and they are asking you the total number of atoms, what is the formula here? I can say total number of atoms is equal to number of atoms is equal to, I can say, number of molecules, okay, multiplied by atomicity, correct? Multiplied by atomicity. Now, first of all, they are telling for 1 liter flask. So this assume that all these are 1 liter flask, and all these are gases actually. Okay, hydrogen is a gas, helium is a gas, O2 is a gas, and ozone is a gas. We know from Avogadro's law. We have learned Avogadro's law. What is Avogadro's law? Can you tell me? Equal volume, equal volume of all gases, equal volume of all gases contains what? Equal number of molecules, correct? Equal number of molecules. Equal volume of all gases contains equal number of molecules. Now tell me, for hydrogen, what is the volume? So for hydrogen, I can say the volume is 1 liter, because gases, they will expand and they will occupy the entire 1 liter volume. And helium, what is the volume? Again, it is 1 liter, correct? Oxygen, what is the volume? Again, it is 1 liter. And ozone, again, it is 1 liter. So we know that volumes are equal for all these gases. Then they should contain what? They will containing equal number of molecules as well. Equal number of molecules, correct? Okay, so let us assume what is this equal number of molecules. So we say let X be the number of molecules present in present in present in hydrogen, helium, oxygen, and ozone respectively, because all will contain X number of molecules. Why? Because all of them have equal volume. So now we will apply the formula. Okay, so the number of atoms of hydrogen is equal to number of molecules, that is X into atomicity of hydrogen. We know two number of atoms in one molecule of hydrogen is 2, so atomicity is 2. So similarly we will write for helium and other atoms. So number of atoms of helium is equal to what? X into 1, because helium is monoatomic. Similarly, number of atoms of oxygen is equal to what? X into 2, because it is a diatomic. And number of atoms of ozone, O3, is equal to X into 3, because it is triatomic. Now if I take the ratio of number of atoms, I will get 2X is to X is to 2X is to 3X. And if I cancel X, I will get 2 is to 1 is to 2 is to 3. So my ratio of the total number of atoms is equal to option 2 is to 1 is to 2 is to 3. That is option A is my correct answer. Suppose in exam they are asking you the ratio of the total number of molecules. Please believe that the number of molecules will remain the same. In that case, the ratio will be 1 is to 1 is to 1 is to 1. Let it be any gas. Okay. So I hope you understood this question. If you have any doubt, please get back to us. And for any detailed theory lectures or anything, you can contact Brainiacs Classes. The question here is, which one of the following pairs of compounds illustrate the law of multiple proportion? Okay, so we know that Dalton's law of multiple proportion, it was proposed by Dalton, we know. So what does the law was stating actually? So whenever two elements combine together to form more than two compounds. Okay, it was talking about two elements. That is very important. Correct. So they combine to form more than one compound. Combine to form more than one compound. Then what it is stating, more than one compound, then the fixed mass of one of the element which combines with a variable mass of the other. So they are making one of the elements masses as fixed, and if you take the mass ratio of the other element, it will bear a simple whole number ratio. Bear a simple whole number ratio. Correct. So we say this as Dalton's law of multiple proportion. Dalton's law of multiple proportion. Multiple proportion. Okay. So how will you apply this when a question is given? That is very important. Now, the most important clue here is this law always talk about two elements combining. Okay, not more than two or not less than two. Two elements combine to form more than one compound. So let's see in the option A how many elements are totally there. Hydrogen is there, oxygen is there, and sodium is there. So it is about three elements. Now, next option, if you see magnesium is there, oxygen is there, sodium is there. That is also three elements. And in the next option, sodium is there, oxygen is there, and barium is there. So that is also three elements. So if you look at the option D, which talks about tin as well as chlorine, here also tin and chlorine. So we can say that tin and chlorine are two elements. Okay, tin and chlorine are two elements. They combined to form what? More than one compound. What is tin chloride? Tin, then tin, the oxidation. So SnCl2 and SnCl4. So I can clearly make sure that, so here I make the tin mass of the Sn as fixed, and if you take the mass ratio of the chlorine in both state, you will get a whole number ratio. So they are talking about the answer here is law of multiple proportion, means option D. So the important point here is for entrance exam when you are writing is, whenever they are asking you the law of multiple proportion, you just ensure that in the option, whatever be the options given, always ensure that there are only two elements, because the whole law talks about two elements combining to form more than one compound. So as per this itself, we will get the answer. So here the answer is option D. So just I will read the question. 0.2 mole of hydrochloric acid and 0.1 mole of barium chloride were dissolved in water to produce a 500 ml solution. The molarity of the chloride ion, Cl minus ion, is. Okay, so this is the question. So you have what? You have hydrochloric acid, correct? So you have hydrochloric acid and you have what? Barium chloride. So BaCl2. These two, it is dissolved in what actually? Water. Okay, so the final solution is around 500 ml. Correct. So we know that when HCl or barium chloride is dissolved in water, it will undergo dissociation. So we say HCl, when it dissociates, it will give H plus and Cl minus ion. So that means 1 mole hydrochloric acid on dissociation gives what actually? 1 mole Cl minus ion. Correct. Now how many moles are given to you? 0.2 mole. So I can say 0.2 mole hydrochloric acid on dissociation will give you 0.2 mole Cl minus ion. Correct. So similarly, we will try to analyze barium chloride as well. Okay. So if you see here, barium chloride, how it will get dissociated? We can say BaCl2 on dissociation in water will give barium 2 plus and 2Cl minus. Correct. So what does that mean? 1 mole barium chloride on dissociation will give 2 mole chloride ions. Correct. Now how many moles of barium chloride is present with you? What is given to you? 0.1 mole of barium chloride, correct? So let me say 0.1 mole barium chloride on dissociation will give me how much? So how to make 1 to 0.1? Multiply by zero point 0.1, correct? So multiply on both sides, this will become 0.2 mole Cl minus ion. Now tell me if you take the solution, okay? So let's assume this is my solution, that is 500 ml solution, okay? So this is my 500 ml solution. Now tell me in this what is the total number of chloride ions, total number of moles of chloride ions present. I know that zero point 0.1 mole of barium chloride will have 0.2 mole and zero point 0.2 mole of HCl will have zero point 0.2 mole of chloride ions. So I can say totally 0.2 plus 0.2, that is equal to 0.4 mole Cl minus ion will be there in the solution. Now let us find the molarity of the chloride ion. We can say the formula molarity is equal to molarity of chloride ion is equal to number of moles of that particular ion. Number of moles is 0.4. So we will write like that, number of moles of the number of moles of Cl minus ion divided by, okay, since it is given in ml, I can say volume of the solution in ml. If it is in ml, then you should multiply by 1000, correct? So if you substitute here, this will become 0.4, okay? Volume of the solution, it is given as 500 ml and this is 1000. So if you do it, this will get cancels and 2. So my answer will become 0.8 molar of chloride ions, correct? So we will see which is there any option like that. So you can see the option D corresponds to that. So my answer is 0.8 molar. So please read the question. Calcium carbonate reacts with aqueous hydrochloric acid to give calcium chloride, carbon dioxide and water according to the below reaction. The mass of the calcium carbonate which is required to react completely with 25 ml of 0.75 molar hydrochloric acid is. So this is the question. Now we have two methods to do this question actually. And if you see this, the equation here, it is balanced, correct? So 2HCl, that means 2 chlorine atoms, here also 2 chlorine atoms, 2 hydrogen atoms, here also 2 hydrogen atoms, calcium 1 atom, oxygen totally 3 atoms, here 2 plus 1 3. So totally we can say the equation is balanced. We have two methods. So let me explain the first method, that is the stoichiometric method. So first method we are going to explain. So I will explain the both methods so that it will easy for you to understand this. Okay. So in the first method, we say by stoichiometric method. Okay, stoichiometric method. Okay. Now, as per stoichiometric method, I know that the stoichiometric ratio of this equation, we know that the equation should be balanced. So the stoichiometric ratio here is what actually I can say 1 is to 2 is to 1 is to 1 is to 1. Correct? This is the stoichiometric ratio. Now, which and all terms we are supposed to link? We need to link between calcium carbonate and hydrochloric acid. Okay. So we will speak only with respect to these two terms. So I can say 1 mole, okay, 1 mole calcium carbonate needs 2 mole hydrochloric acid. Needs 2 mole hydrochloric acid. Now, if you see here, 1 mole needs 2 mole of hydrochloric acid. Now, let us assume they are asking you with respect to mass. So, I know that 1 mole of calcium carbonate is equivalent to how much? 100 gram. So, that means 100 gram of calcium carbonate needs 2 into chlorine 35.5, hydrogen 1. So, I can say 36.5 gram of hydrochloric acid. Correct? Now, what is given to you? That is very important. So, given to you is hydrochloric acid and its representation. They are telling it is 25 ml, correct? 25 ml, 0.75 0.75 molar. So, so which definition we need to apply to get the mass? We know that molarity is equal to, correct? Molarity is equal to number of moles of the solute divided by volume. If it is in ml, you need to multiply by 1000, correct? So what is the molarity of the solution? They mentioned here is 0.75. Number of moles is what we need to find it out. Number of moles of HCl. Number of moles of HCl, correct? Now volume of the solution is how much? 25 multiplied by 1000. So if you cancel this, you will get 25. Okay, how much it will become? 25 into 4. So this will become 40, correct? So what is the number of moles of HCl? I can say number of moles of HCl is equal to 0.75, correct, divided by 40, correct? So this is the number of moles of HCl I am getting. Okay, so we need to find out for this value, that is this value will come around, I can say 0.75 divided by 40, which will come around as, I can say this value is around, okay, let me scroll. So this value is around 0.01875. This is the exact value. So this much number of moles are there, correct? Now as per the definition, I know that 1 mole of calcium carbonate needs 2 mole of hydrochloric acid, correct? So let me rewrite that. 1 mole calcium carbonate needs 2 mole hydrochloric acid. So tell me, let us convert this 2 to 1 first. So divide by 2 on both sides. So this will become 1 mole HCl. And if you divide by 2 here, this will become 1 by 2 mole calcium carbonate. But you have how many moles of HCl? 0.01875. So multiply by that number, 0.01875. Why I am doing that? If you multiply by that number on both sides, I will get this much mole of HCl. 0.01875 mole of HCl needs how many calcium carbonate? I will get like that. So I can say 0.01875 mole HCl, and here only multiplying this will become half into 0.01875 mole calcium carbonate. So I got the number of moles of calcium carbonate which is required for this particular solution. That is how much it is. We have learned 25 ml 0.75 molar HCl, because that is equivalent to 0.01875 moles of HCl. So let us calculate what is this value. So if you divide by 2, this will become, my answer will be 0.009375 mole, correct? So I got the number of moles, but they are asking you the question in grams. So I can say mass in gram, correct? Mass in gram of calcium carbonate. How will you find? We know that we have a standard formula, number of moles is equal to mass in gram divided by molecular mass. So mass in gram becomes what? Number of moles into molecular mass, correct? Molecular mass. So tell me what is number of moles? 0.00937 into molecular mass is, we know that molecular mass is 100. 100 is coming from where? Calcium carbonate. Calcium carbonate has a molecular mass equal to 100. Now, if you do this, you will get the answer as 0.9375 gram. So let's see whether this option is there in the answer or not. Okay. So if you see here, 0.9375 is there. Correct. So this is my answer. So let us try to do this question by other method as well. Okay. So I'll choose another pen. So second method is called the law of chemical equivalence. Okay. So let me say second method, that is by law of chemical equivalence. Law of chemical equivalence. Now, as per this law, what is the law stating? That the law states that the number of equivalents of the reactants and products are always remaining the same. So we can say that the number of equivalents of calcium carbonate should be equal to number of equivalents of hydrochloric acid. So let's find out the number of equivalents of hydrochloric acid. So number of equivalents of HCl is equal to, how to find that? So this is, first we will find it out. So for that, what they have given to you, molarity is given, correct? So molarity is given as 0.75 molar, I hope. Okay, 0.75 molar. So we know that molarity is equal to 0.75 molar. Now, number of equivalents is related with normality. We know that normality is equal to number of equivalents, correct, divided by volume of the solution if it is in ml multiplied by 1000. Now, how normality and molarity is linked? Normality is equal to, we know that, molarity into n factor, correct? So I can substitute here, normality is equal to molarity into n factor. So molarity into n factor. Okay, so number of equivalents is what you need to find out. Number of equivalents. Okay, what is the volume of the solution? That is, they have given here 75, I hope. Okay, you remember, right? So not 75, sorry, 25. So we can substitute that 25 here. Okay, 25, and here 1000 will come. And what is molarity given here? 0.75. And what is the n factor or valency factor? Now we know that here the valency factor or the n factor for hydrochloric acid. So we know that HCl, it's an acid. So this will give only 1 H plus. So the valency factor I can give it as 1. That means normality and molarity are 1 to 1 same. So let's cancel this. So this will become 40. So I can say number of equivalents into 40. So from this I can calculate number of equivalents of HCl. So number of equivalents of HCl is equal to how much? 0.75 divided by 40. Okay, I hope you remember this value. Same value is coming here in another way, correct? 0. That is 0.01875. So I can say this value is 0.01875. I got the equivalents. Now tell me what will be the number of equivalents of calcium carbonate. It will be the same. So number of equivalents of calcium carbonate is equal to 0.01875. This is as per the law of chemical equivalence. Now what we need to find out? We need to find out the mass of calcium carbonate. We know the general formula of number of equivalents. So number of equivalents is equal to weight in gram divided by equivalent mass. Correct? Weight in gram divided by equivalent mass. So number of equivalents of calcium carbonate, we know, we will substitute here 0.01875. Weight in gram of calcium carbonate is what you need to find it out. Okay, so that I will keep it. What is the equivalent mass of calcium carbonate? We know that calcium carbonate, that will split it as Ca2 plus and CO3 2 minus. So equivalent mass of calcium carbonate is molecular mass, that is 100, divided by charge of the cation or charge of the anion. Total charge of the cation or total charge of the anion, that is 2. So you will get it as 50. That is the EQ mass, equivalent mass. Correct? So I get that value as 50. Correct? So tell me weight in gram of calcium carbonate. Weight in gram of calcium carbonate is equal to 50 multiplied by 0.01875. So if you do this, I hope we should get the same answer. Okay, that is 0.01875 multiplied by 50. So multiplied by 50. So you will get exactly 0.9375 gram. Okay. So any approach you can follow, both are easy only. If you understood the concept, it is just a matter of time. You can do it. If the calculation is faster, you can do it very fast. So it depends upon each person. Okay. So we have a new question in front of you. I will just read the question. The molecular weight of a tribasic acid is W. Its equivalent weight will be. Okay. So how to calculate the equivalent weight of a substance? So we know that equivalent weight is given by, okay. So I will use the color, new color I will use. Okay. So what is equivalent weight? I know that equivalent weight is equivalent weight is different for different substances, right? The formula used will be different. So it is a what actually? It is an acid. So equivalent weight of an acid is equal to what actually? The molecular weight divided by what it will be, basicity, correct? Basicity. Okay, now they have given here it is a triabasic acid. So it's a triabasic acid means it can donate what, 3H plus. So I will write here triabasic acid. Okay, triabasic acid means it can donate it can donate it can donate what, 3H plus, correct? So its basicity is what actually? Basicity, I can say its basicity is equal to 3. So tell me what will be the equivalent weight of the acid on substitution. I can say equivalent weight of the acid is equal to, okay, molecular weight they have given as W. So I will substitute W, and basicity we have calculated it as 3. So my answer should be W by 3. So which option corresponds to that? I can say option A corresponds to that.
So this time we have a wonderful question in front of you. We'll just read the question. Okay. 1 liter hard water contains 12 milligram of Mg2 plus. Milli equivalent of washing soda required to remove its hardness is. So this is the question here. So they are just telling there is water is there. Okay. So let's assume water is there. Okay. So let me say this is my water. And what they are saying, so it is hard water, that's why they are telling it has what is present, Mg2 plus is present. Okay, magnesium ion. And they are asking you how much amount of washing soda you needed. Washing soda is what actually? Na2CO3. Okay, so if you can approach this question by two methods, either by stoichiometric method or by equivalence method. So stoichiometric method means you need to write the equation between Mg2 plus and Na2CO3. But if you are applying the law of chemical equivalence, you don't want to write any equations. Okay, so let's go by law of chemical equivalence. I can say on applying the law of chemical equivalence, on applying the law of chemical equivalence, I can say we know that by applying the law of chemical equivalence we can write the number of equivalents of reactants will always remain the same as the number of equivalents of the products, correct? So we can say the number of equivalents, correct, of Mg2 plus should be equal to number of equivalents of washing soda. of washing soda. Okay, but if you see the question, they are asking you milli equivalent. Many students will get doubt when they think about milli equivalents actually. Okay, let's see what is milli equivalence. So we know that milli equivalence, how will you write that? We can say the number of milli equivalents means number of milli equivalents is equal to what actually? Instead of weight in gram, this will become weight in milligram. Weight in milligram divided by equivalent weight. Okay, so don't worry, whenever you say milli, that means weight in gram will become weight in milligram. That's it. So again, how I can rewrite this equation? I can rewrite this equation as number of milli equivalents. Okay, milli equivalents, because we are multiplying by milli on both sides. Equivalents of Mg2 plus should be equal to the number of milli equivalents of washing soda. Correct? Okay, now let's calculate the number of milli equivalents of Mg2 plus. How to calculate that? Substitute weight in milligram divided by equivalent weight. Correct? So this is what you need to find out. Correct? So let's see how to weight in milligram. How much is given in the question? 12 milligram. Correct? So let's substitute here 12. Okay, divided by equivalent weight. So equivalent weight of magnesium. How to do that? We know that atomic weight, that is 24, divided by valency of magnesium is 2. So I know that equivalent weight is 12. So I will substitute here 12. This is equal to number of milli equivalents of washing soda. Okay, so if you cancel this, the value will become 1. So I got the answer. The number of milli equivalents of washing soda is equal to how much? 1. So let's see any option is there like that. So they are asking you milli equivalents of washing soda required to remove its hardness, that is equal to 1. I hope you understood the question.
We have a good question in front of you. The question here is the density of a 3.60 molar sulfuric acid solution having 29% H2SO4 by mass will be. So that means here you have a solution in front of you. Okay, so you have a solution. Okay, so this solution has made up of a solute. So you have a solute, that is sulfuric acid H2SO4. Okay, and you have a solvent, and the solvent is water. Okay, now we have already learned in our theory classes the relation between molarity, okay, density and mass percentage. Okay, so what is that? Molarity is equal to density into mass percentage multiplied by 10 divided by molar mass of the solute. Molar mass. Correct? Okay, so how we can substitute? What is the value given? Molarity is 3.6. 3.6 is the molarity. Density is what you need to find out. Correct? Mass percentage. So how much is the mass percentage? They have mentioned 29%. That means 29 gram of the solute is present in 100 gram of the solution. So 29 into 10 divided by molar mass of H2SO4, that is 98. Now if you multiply, we can say density is equal to 98 into 3.6 divided by 29 into 10. So this will come around 352.8 divided by 290. So how much will be the answer? So this, if you divide, you will get it as 1.216 gram per ml, and that can be approximated as 1.22 gram per ml. Correct. So which option looks the most favorite? So I can say option D is the correct answer. So we have a very good question in front of you. Just read the question. A mixture of 2.3 gram formic acid and 4.5 gram oxalic acid is treated with concentrated sulfuric acid. Okay. The evolved gaseous mixture is passed through potassium hydroxide pellets. Calculate the weight in gram of the remaining product at STP. So this is the question. So this is one of the good question that came actually. Uh, Here we need to know some inherent properties. Then only we will be able to do this. We will see. The first thing you need to know is what is formic acid. Okay, so we will write here formic acid. Okay. So formic acid is nothing but HCOOH. So what will be its molecular mass? We can say its molecular mass is equal to how much it will come? Carbon 12, oxygen 16 into 2 32 plus 12 44 plus 2 46. So its molecular mass will come around 46. Okay, so you can express it in any unit. 46 grams means then this will become more easily. We can say it is molecular mass in grams. Okay. Other single term is molar mass. Okay. Now next one is oxalic acid. Okay, we need to know what is oxalic acid. These are the things you should know to do this question. Oxalic acid is nothing but COOH. COOH. Hope you remember in organic chemistry. So COOH, if you see, you can carbon 16 into 2 32 plus 12 44 plus 1 45. 45 two times are there COOH. So I can say 45 into 2 90. So 90 is my molecular mass. So I write molecular mass is 90. 90 gram. Okay. Now what they are telling, they are taken 2.3 gram given. We will say given. What is given to you? Given to you is HCOOH. How much amount it is given to you? They have given 2.3 gram. And formic oxalic acid, how much they have given? So we will write COOH twice. Okay. So this is around 4.5 gram is given to you. Fine. Okay. Now it is treated with concentrated H2SO4. So let's see what are the properties that concentrated H2SO4 possess. I know that concentrated H2SO4 is used in the chapter alcohols for the dehydration of alcohols. So it is a strong, I can say it's a strong dehydrating agent. Okay, so I can say it is a strong dehydrating agent. Strong dehydrating agent. So what do you mean by a dehydrating agent? It means it will absorb water. It will absorb water. Correct. Okay. So then they are telling the evolved gaseous mixture. So something is you have formic acid and oxalic acid, they are treated with H2SO4 so that some gaseous gas is formed and it is passed through KOH pellets. So we need to know what KOH can do. Please remember, this is a very important thing. KOH. What KOH can do? KOH is specially used for absorbing carbon dioxide. Very important. Please remember this is a property. Now we will start writing the reaction. So you have HCOOH. Okay, now treated with what? Concentrated H2SO4. Correct. Then what happened? It forms carbon monoxide plus water. correct? Now we know that concentrated H2SO4, it can absorb the water, correct? So similarly, next is COOH twice, that is oxalic acid. It is treated with concentrated H2SO4, correct? So what will be formed? Carbon monoxide plus carbon dioxide plus water. This will be the output product. Okay, so we will do the calculation in another color. Okay. Now if you see, then after forming this gaseous mixture, you have a gaseous mixture formed here, correct? And you have a gaseous mixture formed here. So after forming this gaseous mixture, it is passed through what? It is passed through KOH. And I know that KOH, what it will do? It will absorb carbon dioxide. It will absorb carbon dioxide. And we know that what this will do, concentrated H2SO4 will do, concentrated H2SO4 will absorb water, H2O, because it's a strong dehydrating agent. So what is remaining here? So remaining is only carbon monoxide. So remaining is only carbon monoxide. So let's see how the carbon monoxide formation happens actually. Okay, so as per the stoichiometry, I know that I understood that 1 mole HCOOH can give rise to 1 mole carbon monoxide, correct? Now how many HCOOH is present with you? You know that we have done it, we have given 2.3 gram. So let's calculate the number of moles of HCOOH. So number of moles of HCOOH is equal to weight in gram, that is 2.3 given, divided by molecular mass of HCOOH, that is 46. So that will come around 0.05 mole. Now listen, this is what you have. So now tell me 1 mole of HCOH give rise to 1 mole of carbon monoxide. Then I can say 0.05 mole HCOOH can give you 0.05 mole carbon monoxide, correct? Because if you multiply by 0.05 on both sides, you will get 0.05, correct? Because this is what you are having input. I know that 1 can give 1, then 0.05 can give 0.05 mole of carbon monoxide. This is with respect to HCOOH. Now, with respect to oxalic acid, I know that 1 mole oxalic acid, okay, COOH twice, can give how many mole of carbon monoxide? 1 mole carbon monoxide. 1 mole carbon monoxide. Now, what is the number of moles of COOH twice you are having? So I can say number of moles of oxalic acid, that is COOH twice, is equal to weight in gram, that is 4.5 given in the question, divided by molecular mass that we have calculated, it is 90. So it is also coming around 0.05 mole. Now tell me, you have 0.05 mole of oxalic acid. So how much amount of carbon monoxide will be generated? I can say 0.05 mole oxalic acid can give rise to 0.05 mole carbon monoxide, correct? So tell me, after these two reaction, what is left behind? So left behind gaseous mixture is how much? I can say that 0.05 mole of carbon monoxide is present from formic acid, and another 0.05 mole of carbon monoxide is available from oxalic acid. So I can say the total amount of gaseous mixture available is equal to 0.05 plus 0.05, that is how much it will come around if you add it. So I can say if you add that, you will get around 0.1, correct? So I can say 0.1 mole carbon monoxide. But whether they are asking you the answer in moles, you know that it is, they are not asking you in moles, they are asking you in weight in gram. So how can you do that? We know that the formula, number of moles, number of moles, number of moles of carbon monoxide is equal to weight in gram of carbon monoxide divided by molecular mass. Molecular mass means 12 plus 16, 28. Correct. So number of moles we know how much, 0.1. So weight in gram divided by 28. So tell me weight in gram of carbon monoxide left behind is 28 into 0.1, that is 2.8 gram. Understood? So I hope you understood the question. Just I will tell it in one more time. Very simple. They were initially using actually what, formic acid and oxalic acid. So we calculated the molecular mass and everything, and they were using concentrated sulfuric acid. So we know that concentrated sulfuric acid is a strong dehydrating agent. So it was taking away the water that is formed, and it was passed through KOH. KOH, it will only absorb carbon dioxide. So that is also gone. So left behind is carbon monoxide. Next we need to calculate from the given stuff, that is given is 0.05 mole of formic acid, that can give rise to 0.05 mole of carbon monoxide. Similarly, 0.05 mole of oxalic acid can give rise to 0.05 mole of carbon monoxide. So total carbon monoxide available after the reaction is 0.1 mole carbon monoxide. But they have asked the answer in gram. So number of moles is 0.1 divided by weight in gram by molecular mass 28. So you will get it as 2.8 gram. So let's see whether that is present in the options. So if you see, yeah, option A corresponds to that. So that is my answer. We have a good question in front of you. I will just read the question. For a reaction A plus 2B giving C, the amount of C formed by starting the reaction with 5 moles of A and 8 moles of B is. Okay. So it's a clear case. You are given a hypothetical reaction. Correct. So the reaction given is A plus 2B giving C. So we assume this is a balanced chemical equation. Okay. So assume this is a balanced chemical equation. Correct. Okay, now we will apply the concept of stoichiometry. Tell me what is the stoichiometric ratio. So if I see the stoichiometric ratio, you could see stoichiometric ratio is equal to 1 is to 2 is to 1. Okay, now which terms we need to relate? They are asking you the amount of C. Okay, C they are asking, formed by starting the reaction with 5 moles of A and 8 moles of B. So we need to link between these three actually. Okay, now as per the stoichiometry, we will write one statement. We can say 1 mole of A needs what actually, 2 mole of B to produce how much, 1 mole of C. Correct. Now since the given is given for both, what is given to you, given is what they are telling, 5 mole of A, 5 mole of A is given, 5 mole A, and other thing is 8 mole B. And I have taught you, whenever you have reactant, more than one reactants given is given, then there is a case of what, limiting reagent can come into picture. So we need to check which one is the limiting reagent. Okay, but since here we know that the molecular mass or nothing, we don't know about it. So what we should do, how to find the limiting reagent, there is a shortcut I have taught you. So what you need to do is take the value, given value, okay, that is 5 mole, divide by the stoichiometric coefficient. Stoichiometric coefficient of A is 1. So you are getting 5. Okay. And similarly take the given value, that is 8, and take the stoichiometric coefficient, that is 2 for B. Then that value will become 4. Now compare these two values. Compare. Okay. So on comparison, which one is a lower value? Which one is the lower value? That will be the limiting reagent. That will be the limiting reagent. So I understood that B is the limiting reagent here. B is the limiting reagent. This is a common technique. Okay. So B is the limiting reagent. Now everything we can say reaction will proceed according to the limiting reagent. So I know that as per stoichiometry, 2 mole of B, how you can write, needs 1 mole of A, and 2 mole of B will produce what it will produce, 1 mole of C, correct? 1 mole of C. Now check how many moles of B is present with you. You are given 8 moles. Now we need to convert this 2 mole of B to 8 moles. How to do that? Multiply by 4. When you are multiplying, here also you multiply by 4, here also you multiply by 4. So I can write now, how I can write, 8 mole of B, 8 mole of B needs what actually, 4 mole of A, and what it will produce? It will produce, it will produce 4 mole of C. So I got the answer. So how much amount of C will be produced? 4 moles of C will be produced. And how much mole of A will be consumed? 4 mole of A will be consumed. So how much of mole of A will be left behind? I know that 5 mole of A is taken. So amount of A left behind is how much? 5 minus 4. Correct. I will note down that also. Amount of A left behind after the reaction, left behind, is initial value, that is 5 mole minus the final 5 minus 1 mole will be left behind. And what is the amount of product formed? That is 4 mole of C will be produced. So let's see whether that option is there. Yes, option D corresponds to that. So that is my answer.